Record. Gotta record this. There's 4 people falling asleep. Come on. We gotta get going pretty soon. Okay. You get over here. You hush. Okay. A proposition. Determine whether the following statements are propositions and give an explanation. Oh, shoot. I can't do this unless I log in. Five oh six, 786, 506, 786. Let's do it. Trying to figure out. I hadn't used quizzes and my phone camera at the same time. So new technology this semester. Thanks for bearing with me. True means it is a proposition. False means it is not a proposition. I believe. I hope so. We got it 7 to 4. So is it a proposition? The sky is the limit. Why is it a proposition? Why would you say it's not a proposition? Anybody got some reasoning here? The sky is the limit. So what makes something a proposition?
It can be either true or false.
Yes, that's what. Yeah. And so I think I probably put the wrong words on there. So when it says true, that means true that it is a proposition. False means false that is not a proposition. So maybe there's some misunderstanding with the way that I worded the solutions or something. I'm not sure. I wasn't asking whether the statement was true. That might have been a misinterpretation. This is the same thing. True means true. It is a proposition. False means it is not a proposition. Ooh, fix that time. I'll probably fix those in for my next class. Who's the one last person? Are we phoning in? All right. There we go. Negation. Write the negation of the given proposition. Then state the choose value of the original proposition in its negation. So I broke this one up. So I think the first thing that you need to do is write the negation of the given proposition. So the given proposition is the Beatles were not a German band. So we want to write the negation of that. And like negation, just to like real quick recap, it means to make something sort of the opposite, right? Like if I want to negate something you're saying, I'm going to make it sort of the opposite. Usually we throw a not. Technically, I don't think I went like this kind of crazy into it, but technically when you see that negation sign, it means it is not the case that. So if you ever go into like a more formal sort of logic class, they will use that phrasing quite a bit. This is buzzing. Where are we at? 9, 10, 2 more. 2 more. I'm not sure it gives you points. I think it might give you points just for putting something in for these questions, if I'm being honest. If you just joined up into Zoom, we are in quizzes. I think you should be able to see that join my quiz in the code up at top. What? Oh, maybe this is a short response. So the Beatles were, what did you say? The Beatles were a German band would be the negation of the Beatles were not a German band.
I put the Beatles are a German band.
Are a German band. So yeah, maybe it's just like, if that's fine. I think I did short response. So that one actually does grade it, I think. So I probably need to go back in there and throw in some different responses like the Beatles are. So now we're looking at the original statements. The Beatles were not a German band. And now we want to determine whether this original statement is true or false. Oh man, don't spend too long on this, please. The Beatles are British. I'll just give you that much. That is not in Germany. So it is true that the Beatles were not a German band. Oh man, what are y'all doing? You're confusing yourselves? And if it's true the Beatles were not a German band, then the negation of it, the Beatles were a German band, has to be oh man. I know it's 8:35 in the morning, but pretty sure people still know who the Beatles are. Whew, that one's a little better. Okay. So the Beatles were a German band. If the original statement's true, this one has to be false. It is the negation. Dun, 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 dun. Okay. Multiple negations explain the meaning of the given. Oh man. Of the given statement which contains multiple negations. Then answer the question that follows. So Sarah did not decline the offer to go to dinner. Did Sarah go to dinner? And so this is getting at what? Double negations. There's two sort of negative words in there. So if you're not going, then hopefully, where are we at here? Then you definitely win. All right, so the next one I think is pretty similar. And statements, the following statements have a form P and Q, state P and Q and give the truth values. Oh, this one has 5 different things we need. So we need P, we need Q. So dogs are animals and oak trees are plants. So we want to pick out, I'm going to stop the timer. Pick out 2 propositions. So the first proposition is P. So whatever that first proposition you see in that sentence, that should be your P. Then we want to state whether P is true. We want to state whether Q is true or not. So P is dogs or animals. But y'all got like 5 things to write here. Q is oak trees are plants. So is P true? Is Q true? And then we want to talk about P and Q. So this I did all in one thing. So y'all are typing in like one solution. Okay. So we want to talk about P, we want to talk about Q. We want to talk about whether or not they are true, and then we want to talk about whether or not P and Q are true. All right, P is dogs are animals, P is true. Q is oak trees are plants. Is that true? Are oak trees plants? Are we awake?
Yeah.
Yeah, and P and
Perhaps.
Q, and both P and Q are true. So when we put them together, they are true. So how many people we in? 9 out of 12. All right. So I think the last one is probably me. So when we put 2 things together, in order for the conjunction or for the and statement to be true, they both have to be true. So and is like really, really picky. Like everything in there has to be true for it to be true. Any questions about this? So this is like a, I can't even think about it right now. A proposition. This is like a proposition. And if we want to put the 2 propositions together, we're putting them together with the word and. That's the next thing I got. There's some truth tables coming up pretty soon. Following statements have that. Okay, so this is the same and sort of statement. So we want to do P, we want to do Q. I want to know whether P is true. I want to know whether Q is true. I want to know whether P and Q are true. I need 5 different things there. Okay, I'm just going to talk about it. I think it's the best thing. So P is all birds can fly. Is that true?
Yes.
I think there's a few flightless birds.
No.
Penguins, right?
Doesn't-
Q is some fish live in trees. I think the book says, does the book say it's true? I think the book might say it's true in the back. Now that I think about it, that's not true. Yeah, P should not be true. Q is, what was it? Some fish live in trees. Let's say P is true, just for shits and giggles. I think let's just say it's true. So if P was Q, if P was true and Q is false, What would the conjunction be? The and, what would they be together? P and Q would be, some people are saying it. Both together, when you put the and statement, would be false. Yeah. So if they're not both true, then all together it's going to be false. So I think I'm just going to hit end. So if you ain't got something submitted, submit it right quick. Yeah, that's what the book. This came out of the book. I totally checked on the book, and so the book said all birds can fly. So the book lies to you. I don't know what to tell you on that. Fish live in trees. That one is obviously false. If you put them together, it is going to be false overall. So if you tell me P is false, you would probably be more correct than me or the book. I don't believe penguins can fly unless you consider their little soaring underwater thing to be flying, but that's not in the air. It's not flying, that's swimming. Get out of here with that. Okay, we got to make a truth table. So I got to stop sharing this and I got to come back over here to my phone. Come on and zoom there. All right, so what we're making a truth table for? P, Q, and R? Q, R, and S. Okay. Hold on, can y'all see that? We're going to do Q, R, S. We're going to do Q and R and S. All right, so did I talk about this in the video? How many different possibilities we're going to have if we have 3? I believe I did. All right. Do y'all know the counting principle? There's a sort of like simple sort of counting principle happening. If I have one proposition, it can be what?
It could be
Won't
true
you
or false.
multiply the outcomes or the possibilities by 2 each time?
Yeah, exactly. 2 possibilities, right? One proposition is going to be 2 possibilities. 2 propositions will be 4. 3 will be 8. Or you can do like 2 to the first power, right? 2 squared, I think is what this is. 2 to the third would also give you the number of possibilities. You're going to multiply by 2 each time. So back when I was in high school, I worked in Whataburger. They did like a sort of thing. It's like there are, and they gave the number of ways that you could order your Whataburger. Basically, if you take every option, you either have that or not, right? So for like ketchup, mustard, pickles, onions, all you're doing is multiplying by 2 a whole bunch of times. And it's just like, it kind of amuses me because it's a really simple way to sort of find a route. Another way, like people will show this sometimes, is you have like 2 roads that go from this city. You have 3 roads that go from this city to this city. So if you count the number of like unique routes that we can take from here to here, you basically get 6 different routes. If you take the first road, there's 3 different ways to get to the next city. If you take the second road, you're doing 2 by 3. It's a simple multiplication principle. You take the number of options there. Since we're doing true or false, there's 2 options, right? And so if we're doing 2 times 2 times 2, there should be 8 different options. So generally, I like to start off with all truths. And then I like to look at the little false dance its way across. So I'll start it off over here. And I'll try to do everything with false in it. A total of 8 different options. And then go. And that's everything with one FOSS. Now I want to think about everything with two FOSSes. And so I do the same thing. I like to let the FOSS dance across. So if I do what? FOSS, two FOSS. And then this guy's going to follow him, FOSS, FOSS 2. Did I do that right? 1, 2, 3, 4, 5, 6, 7. And then the last one, number 8, would be where everything is FOSS. So I know this is a really big table. But if you know your AND statements, this should be a really, hopefully, really easy thing to fill out. So what goes in this first spot?
True.
What goes in the next spot?
False.
False.
Okay. What goes in all the rest of the spots?
False.
False, all the way down. There's at least one false. That means the whole thing is going to be false. So in order for an AND statement to be true, and you can come up with statements for these, right? The sky is blue, the grass is green, the trees are growing, right? If any one of those things is false, then when we put them together with an AND statement, the overall statement is going to be false. So AND is a really demanding sort of word. Okay, and now I got to go back to quizzes. Any questions about this truth table, why it is, how it's the thing? Okay. I think you should hopefully know like the pattern of like that much doing 3. I'm probably not going to make you do any more than 2 or 3. If we start getting to 4, that's 2 to the 4th. That's already what, 16? I don't want to make you write a whole essay on just truth tables, right? That's a little much. Okay, so let's get going. Next question. And take off the timer. Already made this truth table. This is the next question. Come on, load up so I can read it. Interpreting or, I will either walk or ride a bike to the park. Is that inclusive or exclusive? And there is a word right there that should really tell you which one it is. It is an either or. All right, that word either's in there. So inclusive means you're going to do both of them. Exclusive means you're going to do one or the other, but not both. Okay, let's see where we are. So when he says, I am going to either walk or ride a bike, he means he's going to walk or ride. He's not going to do both of those things, right? To get to the park. He's going to do one or the other. So that would be exclusive. So this is kind of like the mugger example that I gave in the notes, right? You don't want them to do both. The next one is an or statement. I would like to scuba dive or surf on my next vacation. So the question is it inclusive? Can we do both of those? Or is it exclusive? Does he mean one or the other and he's not going to do both? Okay, whatever. There's 3, 2, where are you at? One last person. And so this one, yeah, I don't really, if I'm being honest, this isn't the best example for inclusive, right? My example in the notes was something along the lines of you have to score 350 on a TSI or pass a prerequisite class, something along those lines. So if you did both of those, you're definitely going to be admitted into the class. So this one, they're saying it's safe to assume that he would do both of those on his vacation. They are both desirable things to do. So now we need to make a truth table. So let me bounce back over. Switch the technology over. Back to Zoom. And what did it say? R or S? Is that what it said? So how many options am I going to have here? And I usually like to start out with things all true.
Four options.
There should be 4 options. So both of them are true. One of them could be false. There's 2 different ways that can happen, or both of them can be false. Okay. Or an or statement. What should this look like? What does this first line look like? If it's true or true, so if I say the sky is blue or the grass is green, and it's true that both the sky is blue and the grass is green, is it true that the sky is blue or the grass is green?
I think so.
Yeah, this one's true. So this is the inclusive or, right? And in general, when we do our truth tables, when we do logic, we do the inclusive or. So the exclusive or would be the one that's false here. So, but we're in general, we assume inclusive. If what the sky is blue, is it true that the sky is blue or the grass is green?
Yes.
Yeah. And if the grass is green, right? Is it true that the sky is blue or the grass is green?
Yes.
Yeah. And if neither the sky is blue and the grass is not green, so the sky is not blue, the grass is not green, is it true that the sky is blue or the grass is green?
It's false.
This is the one that's false. It's false. So or is like not picky at all, right? It's just got to have like one thing in there that's true for it to be true. So and is really picky. Like if I was to say I want a pony and I want a mansion and I want this and I want that, I want everything, right? But if I'm like, I just want that, or maybe like one of those things or one of those things, it's not really demanding. Okay. So it takes one true for it to be true. In an or statement, it takes all truths for it to be true and a and statement. Did I say that right? I think the next one is it also truth table. P or Q or R is the next truth table. Okay, so P, Q, R. Let me go over another paper. P, Q, R. So I like to make them out to be all true first. So I want you to try this. I'm going to give you like a few seconds to get a head start on me. But I want you to try to do this. And remember, if you got 3 of them, it should give you 8 options. I want you to try to pull that out just for try to get ahead. And like I said, I like suggested a certain pattern, and I do really like that pattern. But if I'm being honest, as long as you got your 8 options and they're all there, and technically you're making a valid truth table, there's not Not incorrect. It's just not the way I like it personally. Slide away on. Okay, so I'm gonna throw down one false by starting there. It's gonna dance its way across. If you make sound effects, you can draw a little bit faster. I don't know about that, but I heard there was a study if you use profanity, apparently hold your hand in a glass of ice water longer. Let me double check 3, 6, 7, and number 8, which is false, false, false. Okay, so I have all these down, true, 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 false. The false dances its way across, and I just throw down 2 falses, let that guy dance, let that guy dance, and then I got all falses. Okay, so for an OR statement, what should this table look like? True, true, true. This one should obviously be
True.
true. So I hope you like at least get that for this one. What do these all look like?
All true except the bottom one.
The bottom one is false. Everything else in the middle is true. So let me go ahead and guess 1, 2, 7, 8. That's it. So you should have like 7 trues. And then that last one should be false. Like if we look across here, like each one of these lines represents a possibility, right? You can also read things like that. Any questions about these tables, about how to make these true tables? These are the things that I feel like you usually throw people for a loop a little bit. Okay. All right, so I need to get back over to quizzes. And what's the next one? 50 something. OR statements. The following statements have the form P or Q. State P and Q give their truth value. So this is another one that where we have 5 different things. And then we'll have to say if it is true or false. So elephants are animals or elephants are plants. So P is which one of those? What is P in that statement? Do I have? We got 5 more because we got more truth tables too. So what is P in that statement? Elephants are animals. Elephants are plants is true. P is true. Q is false. Statement is true. P or Q is true. What do I want to say about that? Seems like most people are getting this along. So obviously, elephants are animals. P is true. Elephants are plants. That is obviously false. The or statement. So overall, if one thing is true, we're almost there. What do we know about it? The proposition overall with an or statement combining them. True, false. And this would be like if we went back and looked at our truth table with the two propositions. Where is it at? I know we used R or S in our truth table, but we could have said P and Q, and we could have said P or Q. And if we look back at that truth table, this is like that second line that we have there. We have a true statement, we have a false statement, and if we say true or false overall, it should be true. Are there questions about this? And what makes this true? Like if I say this, elephants are animals or elephants are plants. If I make this statement overall, the thing that's making this a true statement is this first thing, right? Elephants are animals. So just by that thing being true, the overall thing is true. Okay, y'all are awfully quiet. I hope that's a good sign. Seems like some people are getting it. Seems like some people are sorting it out. Hopefully things are getting sorted like they should. Or statements. The following statements have the form P. Oh man, now we're actually getting into numbers right now. Look at that. There's some stuff that actually looks like math now. What's my P statement there? What's my Q statement there? Is P true? Is Q true? Is P or Q true? Yep, so the P is the 3 times 5 equals 15. The Q is the thing that you probably tried to type, but you ran out of room or something. 3 plus 5 equals 8 is the Q. Are those true? They are both true. And if they are both true, what does that mean about the P or Q? All right, so I'm going to do a few more seconds. I'm going to really slowly move my cursor to end it with the speed of a great tortoise. Okay. Okay, where are we at? Next slide. So the P is that first statement, 3 times 5 equals 15. The Q is a 3 plus 5. P is true, Q is true. Oh man, P or Q should also be true. I don't know if it didn't get typed or if it just didn't get put on there. But the or statement should also be true. True, true, true. Okay. Better luck next time. Truth tables. We got to make another truth table. If P, then R is what we're doing. So we have 2 different propositions. So I want you, while I'm doing this little technology thing, switch it over. I want you to try to make out that truth table before I do it. There is a what, P and R. Let me go to my Zoom. Zoom. Actually, this works. This works. That's probably good. Sometimes you'll see this thing. Arrow R, P implies R is another way. If P, then R, P implies R. So start out with everything being true. About one of these things being false. And I think about both of these things being false. Okay. So there's a few different examples maybe I could give. But like I think in the notes I did what if I flip the switch, then the light comes on. I think that one's pretty direct. It's sort of shows the relationship here. So this is what we usually use to like talk about like sort of like causal relationships quite a bit. If you do this first thing, then the next thing's going to happen, right? So if I flick the switch, then the light's going to turn on. If I flip the switch and the light turns on, is it true
It's true.
that if I flip the switch, the light will turn on? Yeah, that proved it to be true, right? And so basically, another way to think about this is basically I'm saying what the switch operates the light is another way to think about that. Then if I flip the switch, then the light comes on. So if I flip the switch and the light does not come on, is the switch operating the light?
Wouldn't it still be true?
This one? So if I do flip the switch and the light stays off,
It would be false.
yeah, this is the one that would be false. I think you might be thinking about these next ones, right? So if I don't flip the switch and somehow the light comes on, does that tell me anything about the switch operating the light?
No.
No, it really doesn't. So can I say that it's untrue that the switch operates the light?
No.
Yes. Oh no.
No, there's nothing that disproves it, right? So there's nothing that really disproves this. And this is one of those things you might have to kind of swallow a little bit. But this is true. And we have a similar sort of situation happening here, right? If I don't flip the switch and the light doesn't come on, can I say anything about the switch operating the light?
No, it'd be
Nah, I
true.
can't say anything there either. So there's a really weird thing that happens, and it happens because your antecedent or your P isn't met, basically, right? We didn't flip the switch. And so we want to talk about the switch operating the light, but we didn't flip the switch. So there's nothing we can really say about it. These are the things that I said in the notes we like referred to as like vacuously true. We kind of give them the benefit of the doubt, right? We're just like, okay, we'll assume that this thing is still true. So this is the really kind of weird thing. But there's also reasons why they sort of do it with the algorithms that exist as well. There are sort of reasons why they assume them to be true. Okay, so this is what your if-then sort of truth tables should look like. So I know it says P and R, I could do P's and Q's. Like the variable really doesn't matter, right? Too much. It's a variable, I can swap it out for another letter if I wanted to. Questions? Okay, so this is the if-then. Now we're in the if-then statements. We did ands, we did ors. Now we're doing if-thens. These are the three main sort of connectives that we're talking about in this section. Let me swap on back over to quizzes. Swap here too. Okay. And I think now we're going to look you look back at this table and you keep this table around, it will probably help you answer some of these questions. Especially when we're determining truth values of things put together. Okay, so this is the same sort of thing, but now instead of P's and Q's, they're calling them the hypothesis in the conclusion. So in your if-then statement, it's basically going to say if hypothesis, then conclusion, right? That's the sort of setup of if-then statements. And I mentioned it in the notes and stuff. Ooh, let me hit that timer. I mentioned it in the notes, but like if-then statements, they don't literally have to say if-then, right? There's like only if, which I think reverses the order of the things. There's a few different ways to say it. If trout can swim, then trout are fish. So what is my hypothesis in that statement? What is my conclusion? Is my hypothesis true or false? Is my conclusion true or false? So H is that first thing. My hypothesis is if trout can swim. My conclusion is then trout are fish. My hypothesis, trout can swim. Ooh. Okay, so for your hypothesis, you don't put the word if in there. It's just trout can swim. And same thing with the conclusion. Don't throw in the word then. Just put trout are fish. So the hypothesis would be trout can swim. Can trout swim? Is your hypothesis true? It is true. And then the next thing, trout are fish. Is that true? That is also true. So then if we go look back our table, we're talking about that first line where things look like true and true. So if true, then true would be like that first line there. And if we have an if then statement or both our hypothesis and conclusion are true, what does that tell me about the if then statement? That should tell me, if I hit end really slowly, all right, so this is what I was breaking down. I think y'all were getting at this somewhat, if not all the way. So hypothesis is trout can swim. The conclusion is trout are fish. Both of them are true. So overall, this conditional statement, if trout can swim, then trout are fish, is also a true statement. Okay. If then statements, what are we doing now? Same thing, same breakdown. We want the hypothesis, we want the conclusion, we want to know whether the hypothesis is true, whether the conclusion is true, and whether the conditional statement is true. If trees can walk, then birds wear wigs. This is Lord of the Rings. Oh man, that movie is so boring. The trees could walk. No, I actually like Lord of the Rings. It's pretty good. It is drawn out though, a bit at times. And what about the conditional So false and false. What happens if we go look at that table and look across that table for where your hypothesis and conclusion are both false? And this is like the weird thing. They're doing something really kind of weird here. And it's weird because trees can't walk. So I think some of y'all are saying it. Some of y'all are confused because it's a weird thing, which is fine. That's why we're going over it. So overall, the conditional statement. So what should the conditional statement be? Can someone answer that out loud?
It would be true.
It would be true, right? That's like the last line. And it's a bit weird. I'm going to go ahead and end it. Ooh, there's two of them jumped in at the end there. And we'll talk a little bit about it. Oh, get out of here. I don't care about the leaderboard. I want to see it. Okay, so the hypothesis is trees can walk. The conclusion is birds wear wigs. They're obviously both false, unless someone's being a jerk concluding stuff on birds again. But I think they're both false. The conditional, if trees can walk, then birds wear wigs, is true. It shouldn't say also true. It should say true. Why is this thing true? And it has to do with like this thing, right? If trees can walk, trees can't walk. So anything we say after this, we can just kind of ignore. If this first thing is false, overall, the statement, it doesn't even matter what we say out here. It's going to be true. This is one of those vacuously true sort of scenarios. And it creates really weird sounding phrases and stuff. And it doesn't sound right. So, and I know it sounds weird, but this is a true statement. It's never going to happen that trees can walk, so we can kind of rest assured birds won't ever wear wigs, right? Kind of what they're saying there. Boop. Okay. Another if-then statement. We got to break this down. Hypothesis, conclusion. Are they true or false? If dogs can swim, then dogs are fish. So what's my hypothesis there? What's my conclusion there? And then what is the conditional statement overall? Is it true or false? And again, if you want to go look back at that table, it might help you on these. H is dogs can swim. C is dogs are fish. I hope you know that H is true for the most part and C is false for the most part. Unless they're dogfish, but no, I don't think that's what they're talking about. And then we'll talk about the overall statement in a second. So what line is this like? If my hypothesis is true and my conclusion is false. I feel like I left something out of this homework or something. It looks really long when I look at the sheet. All right, so I think this might be the last one. There's one person that hadn't answered, I think. If dogs can swim, then dogs are fish. So my hypothesis is dogs can swim. My conclusion is dogs are fish. So my hypothesis is true. My conclusion is false. If that is the case, this is like that second line from our table. If my hypothesis is true, my conclusion is false, this is the one thing that proves that the conditional statement's false. And hopefully this makes sense, right? If I say if dogs can swim, the dogs are fish. Dogs can swim and they aren't fish. So therefore, like saying this would be a false statement. Them swimming does not make them into fish. Is that hopefully making some sense? Where? Any questions about this one? I think this is the last one, huh? Where are we at? Let's see. Oh, I did the worst. Look at that. All right. So what do y'all have to do? What's the assignment? Today is Tuesday.
Are you talking about the homework?
Yeah. So we did 1B today, so you should submit this by what? Tomorrow at midnight, I believe.
Yeah.
And then before next class, what are y'all gonna do?
Watch the video.
The video for 1C. So did I talk about like where we're kind of leading with this stuff? In the last class, like in the last class, I just taught 1A to them like yesterday, right? And that was all about the logical fallacies. And so I had a student that was like, "What the heck does this have to do with math?" She's like, "I'm learning all this stuff in my English class." So I think they were like, she's like a little bit confused, like why we start off with the logical fallacies, right? So logical fallacies, I think they're trying to show you obviously the wrong way to do something, right? The wrong way to draw a conclusion from premises. And so we're trying to get into the right direction of drawing a conclusion from a premises, from either deductive logic is what we'll talk about, or the other sort of logic that's also used is inductive logic. So we're going to talk about deductive logic, and that's basically like math's main game right there, right? Is doing deductive logic. In science in general, right? We like to do this thing called deductive logic. And so we will talk all about that. Section 1D, I think, is where that comes up. So 1A was about logical fallacies. 1B is the thing we just did, was about propositions, their connectors, like ands, ors, if, thens. So the conditionals really open up like I feel like a can of worms there, so to speak, right? With things that we can sort of do. And so we did propositions and connectors. I was going to talk about that too. That's the next thing I'm going to talk about. Let me write it down. And then 1C, we're going to talk about Venn diagrams. So basically, we're getting into like set theory and how to like do that. What do I say? Visually, I guess, like a visual representation of sets. We do this with Venn diagrams, so we will be talking all about Venn diagrams in 1C. And then by the time we get to 1D, that's when we'll get to analyzing arguments and talking about whether something is valid or not, talking about deductive logic, talking about inductive logic. And so you might have noticed the homework for 1D, I didn't even pull from the book. I like that logic worksheet. And so it teaches you to use a Venn diagram to determine whether or not an argument is valid. It's basically kind of like where we're going with this whole chapter 1 stuff, at determining the validity of an argument. And then after that, we're going to hit up chapter 10 for like A and B, and that's just some some geometry stuff that we're gonna throw in there. Just so we don't have an entire test over logic, I guess. We're gonna throw in 2 chapters of geometry up in there. And then we'll take a test. Any questions about where we're heading? Anything that we've done? Anything? Oh, the other thing, like we did if-then statements. Let me get my camera out again. Did y'all ever like go into like have a come on up this way? Here we go. Did y'all ever have like a geometry class or something where they made you like write out definitions and you're like, did you ever do this stuff? Sometimes they will do it an if with 2 F's to abbreviate it because we do it so often. Do y'all remember writing this or no?
I believe that we did.
Yeah, and what'd y'all write these for? These were all like sort of things that you gave that were like definitions basically of things, right? So when we go like defining things or doing like theorems and axiom, well, yeah, axioms or theorems. When we do like theorems or definitions of things, if and only ifs, is some of the phrases that we'll use. And so we talked about if P then Q, and I said something like if P then Q is like this thing, and this is known as a conditional. And then there's this thing called P only. Oh. And that's kind of like the thing going the other way. I guess I could go Q arrow P, right? Or I guess I could do the arrow this way. Like this is my antecedent and this is my consequence. And so this is like an if statement. This is sort of like an only if statement. If we put them together, we get something like P if and only if. I'm doing it wrong. P, I think it goes something like that. Is what they'll do sometimes. If and only if Q, and this is actually how we define things. It's only true if both of them. I believe it's true here and false here. And so it's only true if they're both true or if they're both false. And so that's one way that we make things kind of the same. It's the way that we make them say, hey, they are the same thing. It's one way that we actually define things in math is with if and only if statements. And it's like we do a conditional and we do a conditional both ways. Sometimes you'll hear that word biconditional. And a biconditional statement is actually how we start to sort of define things in math. So that's probably more than you wanted to know early on a Tuesday morning, but there you go. Any questions about anything? I think that's about all I got for you today. We got about 4 minutes of class left. I think that's pretty good.